Nevertheless, you will be calculated. Can you hear me fine? No. Base water. You come here and access.
Don't be sorry.
Why is water? Hello? Yeah. Okay. Hello? Yeah. I think that's good. Not good? So you come front. Right? Actually, I also want to say that less energy expenditure, less metabolism, less appetite. Okay, so did you complete this problem? Saksham, did you complete this problem? So what about this part? Acceleration of point A, did you get that? Anyone who has got acceleration of point A? 2.106. So you need omega cross R, then omega cross B. Here you can directly write the B components. But there is one part in the question which says, in addition to the motion described, the vertical shaft and point O have a linear motion. Say in the Z direction. So the vertical shaft and point O have a linear motion along Z direction. Would that motion change the angular velocity or the angular acceleration? Food for thought. How do you answer this question? So the question is, if point O is given a motion along the Z direction, will there be any change in the angular velocity and angular acceleration of the rigid link OA? So the other motions are there. You have rotation about Z, you have spin about X, okay. And in addition, you are having motion along, linear motion along Z direction. So will there be a change in angular velocity and angular acceleration? No. How many of you say no? And how many of you say yes or yes? So to those of you who say no, what is the explanation? That is the function of n and beta dot. That is a good observation. And if you move the link along OA, that is a linear motion. That is quite independent of the angular. Do you notice one thing? We say velocity at a point. Suppose something is moving, we say velocity of the center of mass. Angular velocity is not about point. It can be about an axis. Okay. Now, the body, if you have a body, I cannot also make statements that angular velocity of A, let's say, and angular velocity of some point on the rigid link will be different. Can it happen for the rigid body? No. How do you define angular velocity? So suppose if I want to define angular velocity of this object over here, I actually draw a line. Right? Yes? Problem or not? Okay. You going too much? Still deal with it. So you have this remote control and you want to find out the angular velocity. How do you find the angular velocity? So you mark a line, okay, and at instant t there is some angle, and let's for simplicity assume rotation along the means motion in this plane. So if this is the line, after some time the line becomes like this. So this del theta in del t is your angular velocity. It is not dependent on any point in space, rather also the motion of any particular point, but rather how a particular line changes its orientation. Okay, so that's why your motion about O, linear motion about O will not change the angular velocity. But let's say if you have rotational motion about x, then angular velocity will change. Rotational. Here in the question it is saying linear motion. But agar rotational motion hai, obviously now you have a added rotation component. Okay? So you have to remember this part, that it is angular velocities are not dependent on any point in space. Now all of you try to solve this problem. All of you should solve this problem. So let's make an effort post-exam to improve ourselves. Two problems. So here you have a motor which spins along this small z axis, and the spin direction is like this. So if you curl your right hand along omega, your thumb points towards small z axis. In addition to this motion, this foundation of the motor also moves along the capital Z axis. And the angular velocity sense, if you find, curl your fingers, it is about the positive Z axis. And this gamma for this problem is assumed to be constant. So we assume that there is no motion like this. Okay? So the first part of the question is determine the angular velocity and angular acceleration of the disk. Also notice in the problem what it is saying, angular velocity of the disk, not at any point. Velocity for a point, angular velocity for the body. And angular acceleration of the disk. this is how you draw the diagram. In the exam, try to draw very simplified diagrams. Don't try to draw isometric diagrams. So, anyone with the answer? Anyone else would have solved? Right, omega capital Z plus omega small. That is correct. So you have to resolve k cap along small y and small y. Either you resolve this along this or this along this. So one way of doing it is you understand that your omega naught is some omega, how much it is, 120 revolutions per No, this is capital K. This is capital K. So you should convert the omega vector to a particular coordinate system. One given coordinate system is x, y and z. So you can convert capital K. So this is capital K vector. So capital K cos gamma is J cap, sin gamma is K cap. This is small k. This small k is along this direction, right? Yes, small k, and this is small k. K is a unit vector. It is having an angle gamma with, if this is gamma, this is also gamma. So 2 pi cos gamma plus sin gamma. So omega is 1 pi k. Is gamma given to you? OC and CK is given and it is 30 degree. So 2 pi cos 30 is what is the plane in which the instantaneous angular velocity vector is located? The plane containing the instantaneous angular velocity vector. Plane is given by two axes. No, not xz. Xz you understand is into the screen. Y. So it is line on. Because though I have written it like this, I think this adds, right? 5 pi. So you can see it is whatever is the total, and this is the total angular velocity vector. What is the direction of instantaneous axis of rotation? How do you get it deterministically? I mean, I want to define the exact angle. How do I do it? Right, so I get the direction of omega vector. So it is some units k and some units j. So if you get this angle, how much is this length? Pi root 3. How much is this length? So tan inverse of pi root 3 divided by 5 pi. Is it okay? Any questions? So can you tell me what will be the space cone? So which vector should I consider? This, right? And how should it rotate? About the z axis, correct. And what will be the rotation? This will be rotate with this angular speed, right? What will be the body cone? Fixed like this. And so you will have pure rolling of body cone around the space cone, and the line of contact will be the instantaneous axis of. So there is no point hurrying. You first understand these things. What will be biggest failure is that at some point of time, if you tell your interviewers that I have taken advanced dynamics and you can't answer questions in basic dynamics, then they will ask you on what I have. So if you are able to do something okay, or if you are at least bring this knowledge to use someday, I will be very happy. Okay, so how do you determine the angular acceleration? Angular acceleration के लिए first thing you should focus first on the angular velocity vector. इसको देखिए और इसको पार्ट बाय पार्ट स्टडी कीजिए. ये क्या है? What is this? Omega naught. What is the direction of omega naught? I. K क्या? Okay. And what is this? You tell me. Okay. Precision. It is called precision about capital K. तो ओमेगा में दो चीज है, एक है ओमेगा नॉट है और एक ये. Now your name is Dimrij. Dimrij, tell me what is omega naught? Is it changing in direction? You tell me. Is omega naught changing in direction? Omega naught is not changing in direction. You?
Changing in direction?
You are asking me or telling me?
No, I'm thinking.
Anupam, omega naught is not changing direction. It is changing direction.
It is.
Okay.
It is rotating.
So, how is it changing direction?
Rotating around the Z
Rotating
axis.
around. So he has finally understood. Omega naught is rotating. He is correct. Omega naught is rotating about the capital Z. ठीक है. तो is there any change? कौन है? हाँ. Is there any change in direction and magnitude of this? No. Do you agree? Reason? It is fixed in direction and magnitude is constant. तो आप लोग को ओमेगा को देख के देखना है कि कौन पार्ट कैसे कैसे चेंज करता है. Then you take the time derivative. Now when you take the time derivative, this part does not exist, like Stanzin said. Your name is Stanzin, right? Because it is fixed in direction, fixed in space. And like Pratyush said, omega naught is changing with time. तो ये ओमेगा नॉट कैसे चेंज कर रहा है? ये मेरा द ब्लैक मार्कर इज द कैपिटल Z एक्सिस, ब्लू मार्कर इज ओमेगा नॉट एक्टिंग अलोंग दिस डायरेक्शन गामा. ये मेरा स्मॉल Z एक्सिस है, ये कैपिटल Z एक्सिस. एंड दिस अबाउट द कैपिटल Z एक्सिस देयर इज प्रिसिशन. तो ओमेगा नॉट कैसे चेंज कर रहा है? ये एक कोण ये भी ट्रेस कर. And you remember this, a vector which rotates about a given vector, what is the rate of change of that? Omega cross that vector. Remember this diagram. If you have a vector r, consider this vector r and consider this omega. तो r ओमेगा के अबाउट ऐसे ऐसे जा रहा है, तो dr dt क्या हुआ? ओमेगा क्रॉस r. तो उसी तरीके से डी ओमेगा नॉट डी टी क्या होगा? हाँ, बट यहाँ पे किस ओमेगा से घूम रहा है? If you have not understood, I will explain once again. you compare this diagram, the first diagram, ओमेगा और आर का जो डायग्राम है उसको आप कंपेयर करिए इससे, ये जो प्रॉब्लम है. This is capital Z and this is small z about which omega naught is there and it is precessing. तो उस डायग्राम में क्या था, ये ओमेगा था और ये आर था. तो d r dt was omega cross r. Similarly d omega naught dt will be this omega cross this. तो ऊपर वाला वर्टिकल ओमेगा क्या है, ये क्रॉस. So it is omega cross. Is this clear? Now you find the angular acceleration. But before you do that, both vectors should be expressed in the same coordinate system. आपने ओमेगा को ijk में यूज किया और ये जो है इसको भी you have to express. So you write 2 pi cos gamma j plus sin gamma k cross omega naught. So k cross k, any problem? K cross k 0, j cross k I. So you will get alpha pi square, right? Cos gamma pi square omega naught is 4 pi. Right, omega naught is 4 pi. So ये हो जाएगा 8. So your alpha is ready, omega is ready. आपने पहले ही निकाल लिया. Now what you have to find? You have to find velocity and acceleration of point A. So what were the expressions we have found out? Velocity of a point A is omega cross
R.
Remember, when you are writing omega cross r, this r is measured from which location? This point. Very good. It is measured from this point. But obviously, applications will be more involved than this, and finally that point O will move. So in the next class, we will deal with class of problems where point O will also move, and then if it moves, you have to add plus VO, and this will be the relative velocity. What will be acceleration of A? Again take time derivative of this alpha cross r, which is time derivative of omega, plus omega cross time derivative of r, which is again omega cross omega cross. So what you can do when you are writing for the cross product, you can replace it as omega cross now what is r? Omega you have found out, alpha you have found out. You have to express r in which coordinate system? A coordinate system में सबको express करें. तो r क्या हुआ? First you will go OC. ये किसमें? 10 by 12, let's say, and then 5 by 12, J. Or you can leave it in inch. बाकी कोई यूनिट का तो कुछ है, you can also leave it in inch. तो R क्या हुआ? R is 10 A plus 5. Now it is slogging. Do cross product. If you know symbolic computation or your calculators, I think also do cross product. Have you done cross product in your calculations? But you know, if you do it manually, there will be chances of error. Of course, if you practice, those chances will be. ठीक है, we will not waste time on just cross products. You have understood, right? Any confusion how to get these steps? Alpha आपको दिया हुआ है, R दिया हुआ है, you have to do alpha cross R. Omega cross R you have already calculated, that is E omega cross B. Okay, so you have so far seen two problems where angular velocities were constant in magnitude. So now we will look at a case where all the angular velocities are now also changing to magnitude. Can you see this blue arrow? I don't think you will be able to see. ये ऐसे about y, about y. So I give you some time and I want you to compute omega quickly of this disk. First you compute omega of this disk. I think this arrow is quite vivid, so it's about small z. how will I represent another angular velocity? One is omega s, another is
omega p.
the fixed point is
O.
O. It is not mentioned here. But first I have asked you to find angular velocity of this. Oh, you are saying the answer. How much is omega? 10 j cap. Good. Maybe in coming test we will see less number of figures. Okay, omega is 10 j cap plus 12 k cap. That is good. Then what to do? Next step. One thing the problem will not tell you. See, in this problem what it is asked? Velocity and acceleration of point C. ये कोई भी कैलकुलेशन करने से पहले you have to be ready with omega and alpha. Without this, if you directly solve for VC and acceleration of point C, there will be chances of making mistakes. तो पहले प्रॉब्लम में अगर वेलोसिटी एक्सेलरेशन किसी पॉइंट का दिया हुआ है तो फर्स्ट सॉल्व फॉर the angular velocity of the body. Now, let me write it symbolically. What he said was a numerical answer. तो ये ओमेगा किन दो ओमेगा से बना है?
P omega p
ओमेगा p,
omega s.
ओमेगा s. Now you individually look at the time derivatives. ठीक है? So first let's start from you. Tell me the time derivative of omega p. Omega p time derivative is 3 radians per second. Will there be anything else? नहीं, omega p का time derivative पे सिर्फ बात करें. Forget about omega s. अभी सिर्फ omega p का time derivative. So he said omega p time derivative is 3 radians per second square as given. I am asking you if will there be any other terms? सिर्फ 3 k cap. So he is saying सिर्फ 3 k cap होगा. Correct? Why is it correct? It is along constant direction. ये कैसे भी रोटेट करे ओमेगा p का डायरेक्शन इज ऑलवेज अलोंग नाउ यू टेल मी वैभव व्हाट विल बी ओमेगा s डॉट टाइम के रिस्पेक्ट में चेंज कर रहा है तो क्या होगा 6j क्या करेक्ट सो यू हैव अंडरस्टूड Very good. Omega p dot plus omega s dot, but there is a twist. Omega p dot में सिर्फ डायरेक्शन चेंज नहीं हो रहा है, सिर्फ मैग्नीट्यूड चेंज हो रहा है. तो there is 3 rads per second square k cap plus omega s. Like he said, there is change in magnitude. What is the change? 6 rads per second square. What is the direction? K. Plus, now you notice if दिस इज ओमेगा एस, ये y मान लेते हैं, एंड दिस इज z. So this omega s is changing direction. Why? Because of the rotation about z. So this part we will write as omega p cross omega s. तो ये ओमेगा p क्या है? 12 k cross 10, right? k cross j minus I, so minus 120, right? So if you want to rewrite alpha, if you write the total alpha, you get b k 6 j minus 120 Any questions here? I am ready to explain again if you have any doubts. Now what do we have? We have alpha and we have alpha. Now you have to use these expressions. For which point? C. C का R वेक्टर क्या है? 0.15. So this class of problems, ये जो आपने 3 problems देखा, do you now feel confident कि अगर ऐसा आएगा तो कर लेंगे? So we will proceed by class of problems. ठीक है? So I make a appeal to all of you that from here after be sincere in the class. Class में आओगे we will do problems. If you remember, even in mid-sem, the day before and previous classes I had discussed similar problems, but still your performance was terrible. Okay. So now you make an effort to understand the problems, the way it is done. All of you should do problems. अगर भी लग रहा है कि नहीं समझ में आ रहा है, कुछ नहीं हो रहा है, you ask me, you ask my PhD student, you ask the senior and tech students, those who had scored well. So, 2 of you I think need serious help, otherwise you will fail for sure. So let us